their presentations, they stick to the time so that we have adequate time for discussion. As you experienced yesterday, there are very many people that would like to contribute in the discussions, and we do not want to deny them that opportunity. So if you know you are making a presentation today, please make sure that the presentation has been given to the Secretariat so that they can organize the presentations, and therefore we save on more time. And having said that, I don't want to waste any more time. I would like to again call upon the chair, that is Dr. Farombo, and the moderator, and the rapporteur, Dr. Charles Waboga, to take the session from here. Thank you, and have a very useful deliberations today.
Thank you very much, Chairman. We are going to continue with the two remaining oral presentation for yesterday. I'm going to call Patty Mpiana, who is going to talk about the immunotrypanolyse, la clé de l'élimination de la THA à l'horizon 2030 in DRC. You have 10 minutes.
Thank you. Morning, everyone. Thank you, Mr. Chairperson. Thank you, Mr. Moderator, for to give this opportunity to talk about my work. And Mr. Chairperson, I will be comfortable to talk in French. Slide. Du pointer. Yeah. This. Je peux faire manuellement pour gagner le temps. Nous allons présenter les travaux qu'on a effectués l'année passée sur les rôles que joue la trypanolyse pendant ces moments cruciaux de l'élimination de la maladie du sommeil. Comme vous savez, parmi les présentateurs, il y a peu de cas, de nouveaux cas qui sont maintenant notifiés au Congo, Kinshasa. Pourquoi? Parce que il y a plusieurs causes que les programmes, je crois, avaient énuméré ça. En ce qui concerne la situation de la trypanosomose au Congo, jusque-là, c'est un terrain qui est vide. Il n'y a pas encore de données fiables qui peuvent, n'est-ce pas, slides. Néanmoins, on a fait quelques études pour voir si on pouvait trouver.
If we could find these reservoirs, and that's what we're going to present to you as the results. Concerning the situation of the sleeping sickness, the program had already talked about it. We are not going to waste time on that. But what we have observed is that several seropositives who are screened apart from rapid diagnostic tests which exist, and these seropositive people are obliged to go through a trypanolysis. And we do observe that we presented the tools for doing the screening, and these tools are limited. We need to find more or improve upon existing tools. And these tools orient the diagnosis, and this has to go through tripoanalysis. Tripoanalysis remains the serological test, which actually gives a high specificity as compared to existing tests, especially CAT, and also the rapid diagnosis test, which we call chromatographic test. According to our study, and also the studies of other researchers, do show that the big reservoirs of sleeping sickness is the man, the human being himself. But we need to also look in other places, because we want to eliminate the disease, so we have to look for this even among the animals. So we carried out this study in the province of Central Congo, and also a part of carried out in Kinshasa. We went nearby, and we took advantage of our doctoral students who are working on lonchocercosis and schistomiasis, and were able to take some samples. We were able to take some samples in a neuropsychiatric center where we have sick patients presenting epilepsy, because we wanted to know, in the case of cystic psychosis, if the cases of epilepsy as regards these pathogens. If it is, since in Burma it is a hypo-endemic center, we prefer to do a tripoanalysis with these patients, and we wanted to do tripoanalysis with these patients because this is a very endemic zone. We did the same thing. We did the same thing for the case of the onchocercosis. There's a student working in Kipevolo where DNDi works. We wanted to see if we could take some from animals which harbors the onchocerca species, which is very close to onchocerca. India is one of the zones which notified the case, and therefore we took samples from animals, from dogs, from pigs, to see what that could give. And from all these samples taken, we observed that with the man, we tried to do some immunochromatographic, but the rapid diagnosis text doesn't work with the animals. We had 2 cases which were positive for the human beings, and for pigs you can see 83 cases which are positive for pigs, while tripoanalysis gave 2. We observed that patients who had epilepsy, we took samples. We had positive samples in Burma. through trypanolysis, it was positive, but with parasitological approach, we were not able to see the parasite. We were able to take the parasites which we found. We took it to Boko Kivulu. Boko Kivulu is in central Congo, towards Benizongo, in a silent focus. And we found the parasite congolensis, unfortunately, but for the positive cases, we tried to do the PCR on the sample, and the PCR test just gave the profile of the Brucei species. We don't know whether it's Brucei congolensis or Brucei. So up to there, we don't have in Congo, as compared to other countries, we haven't found Gambiense in animals. That's a problem. We think we shall continue with doing research, isolate some species after having doing trypanolysis. So the species which we shall isolate, even if we treat the presumed patients who are presumed positive, we should think about the future, because the disease could come back and we may have some sources in our bank for doing studies on receptors of different medicines which we're using today. In conclusion, we have to make a supported effort in order to explore in the zones where there are seropositive cases. We should explore animals so as to see if there would be some eventual Gambiense which would be hiding, and then we compare that with Gambiense which we find with human beings, and then we define the role of transmission of this disease. Thank you. Thank you, Patty, Professor Patty. We give the floor now to Lucas. I wonder if he's in the room. Lucas may come forward for a presentation. The presentation is entitled You have 10 minutes. Active search for unconfirmed HAT serologically positive individuals.
I'm here to present our pilot study that we conducted in the DRC. It's a pilot where we test a new passive screening strategy, also exploring the different confirmation techniques. I would like to start by thanking our partners, because this has been a team effort with the ITM, the INRB, and the National Program of Trypanosomiasis Control. So some of the implementers are also present here, such as Professor Alain Pagna, Dr. Julien Choa, and Raquel. So before we start, already thank you. I just have the privilege to present you our preliminary results whilst waiting for the correct presentation. Yeah, that's the one. Next slide, please. Slide, please. Nope, it's the same presentation. So On the first slide, we had the different strategies. Luckily, Dr. Ramon already explained where we are and which direction we're taking with the strategy when we're going towards elimination. So I would just like to stress the interaction between passive screening and reactive screening. So that's also implemented in our model, is that when we do find a case, we would like to send mobile units. Oh, that's the one. Next slide, please. Slide, please. Yeah. Thank you. Even better. So yeah, these are the new strategies, but well, that's also already has been explained yesterday. This is not working. So we introduced a model across 23 healthcare facilities across 3 provinces, Kasai Oriental, Lomami and Sankuru, as indicated by the green arrows. And the 23 healthcare facilities we categorized into 2 categories, a full diagnostic package and a minimal diagnostic package based on surrounding disease prevalence. I will now explain you the full diagnostic package. So let me walk you through our diagnostic algorithm. So it's a passive screening strategy. Patients present at healthcare facilities. When they have suggestive signs or symptoms, the clinician can refer them now for the test. We use the Coris HAT0 cassettes for model. If negative, we have excluded trypanosomiasis. If positive, we will now seek to confirm trypanosomiasis with 3 different confirmation methods. All these 3 confirmation methods will be eligible for treatment. So first of all, in the full diagnostic package, the lab technician will search for lymph aspirate in case of cervical adenopathies. Sometimes they might even look for trypanosomes in the cerebrospinal fluid if there are strong clinical, neurological, suggestive symptoms. But almost all of the time they will take a blood sample to look for trypanosomes with the mini-anion exchange centrifugation technique. If in any of these body fluids trypanosomes are detected, they should take a video, which is then being sent to the national program to do quality assurance of these confirmation, and at the same time, simultaneously, so they will also collect a blood sample with a new blood sample collection kit, which is now being routinely used in the DRC. These blood samples are being sent to the INRB, where they will conduct the ELISA, the trypanolysis, and the PCR. If PCR or trypanolysis is positive, we now speak of a serological confirmation or a molecular confirmation. So at the bottom you see 3 confirmation methods we used for treatment. ELISA, thus far we authorization to treat those confirmed patients yet due to specificity issues. This is so the simplified diagnostic package, which is kind of the same, only we don't have the microscopy and we just have the blood sample collection kits. Clinicians are still able to refer patients to full package facilities for microscopy if they are not at ease waiting for the results, which can take some time. So that's a simplified package. Okay, so now for the results, I think we can go through this quickly. We have trained 258 clinicians, 67 lab technicians across the 3 provinces. So the clinicians are doctors and nurses, and they have been trained by a team of 14 experts from the 3 different institutes. For the more relevant results, we have had 32,245 curative consultations, so patients presenting themselves at our facilities, of whom 2,888 clinical suspect has been retained, so that we screened, which gives us a 9% screening ratio, so almost 1 out of 10 patients presenting, we did a rapid diagnostic test, and of those patients, 328 patients became serological suspects. So clinical suspects have now become serological suspects, which we now seek to confirm, and out of those 328 serological suspects, we analyzed 165 patients microscopically, so in the 13 healthcare facilities with the full package, and all of the patients had the blood sample collection kit for the post hoc confirmation. Out of the 165 microscopically analyzed patients, we only had 1 confirmation, and out of the 266 results we know from the 328 tests we've taken, we have had 5 molecular confirmations, as you can see on the right, 5 PCR positives, 27 positive ELISAs, and 16 positive trypanolysis patients. So since March, that's when we kicked the model off, we have treated 18 patients up to date. Next slide, please. So I think these are quite interesting results, which also allows us to pose a lot of questions, such as why are the confirmation tests so different? We have 1 or 4 PCRs, 1 microscopy, 27 ELISA. So there's not a lot of concordance, which allows us to raise some questions, like how are we going to define the case? I think we can all agree that the threshold now to treat the patient should be lower than the threshold to trigger reactive screening, or the threshold to define this case as a true case that we're going to map with cartography, and we don't want our numbers going up either. So maybe we should take a combination of confirmation to trigger reactive screening. All these questions are so for interesting discussions to be followed. But apart from that, we also noticed in our model it has some flaws. It hasn't been easy. It sounds that there's a lot of potential in the post-hoc confirmation tests, but as you can see, it comes with some logistical difficulties to be in the middle of nowhere in Sankuru without any mobile phone connection, let alone internet, no electricity. We need a cold chain to preserve the RNA if we want to preserve the RNA, and we have also noticed that the time between the blood sample collection kit and the results can take up to 2 to 3 months, which might be a long time if patients present really late with severe symptoms. Therefore, the option to refer should always be present. Next slide, please. To conclude, I think this model has shown that post-hoc confirmation tests demonstrate promise as a viable alternative to on-the-spot microscopy, and that maybe the performance of diagnostic accuracy in lab technicians that aren't experienced by doing microscopy, maybe the performance is questionable. How about specificity of lab technicians that have never done the mini anion exchange centrifugation technique before? So I think that we should continue using both confirmation techniques, but what is sure is that there are multiple projects and multiple partners currently working with the passive screening strategies in the DRC, and the idea is to harmonize and to come up with a unified strategy. I think this model has shown us quite some interesting data and learned us quite interesting experience to propose such a scalable model which is suited to DRC healthcare system. So thank you very much for your attention.
Thank you, Lucas. The next presenter is Nick. Et va parler sur éclairer la voie de l'immunotrypanolyse pour les diagnostics de la trypanosomiase à TB gambiensis. Nick, you have 10 minutes.
Thank you very much. Thank you very much, ISCTRC, for allowing me to present my work on the fluorescent trypanolysis. Great. So as my colleague, Professor Piana already said, the trypanolysis technique is a golden standard standard for Gambiense diagnosis, diagnosis, because it's much more specific than CAT and the rapid diagnostic tests. So in the end, it will allow to have a conclusion about the seropositive result of these tests. When you're positive in trypanolysis, you're considered to be a serological case, and when you're negative. The technique, however, is only available at a few WHO collaborating centers that we have. And the main reason is because this technique is difficult to perform. You need some infrastructure to do it because it only works with human infective parasites, so there's a considerable biosafety risk. And you need also rodents, an animalarium or an animal house to perform rodent infections. The second part is also that the sample preparation is quite intensive because we have to process every sample twice. You have to first test it for LITAT 1.3 and the next round you test it for LITAT 1.5. So that means that before you have a result, you have to do double the work the entire time. The last problem that you may have with the current technique of trypanolysis is that it's very subjective, the readout. So you phase contrast microscopy to visualize the dying parasites, and in the end you have to estimate the percentage of lysis that has occurred in reference to a certain control that you're using. So there's much room to improve this technique, and we try to do it in several ways. So the first step that we take is to make the trypanolysis a bit more safer to use. And for that we used the organism Trypanosoma brucei, which is by definition non-human infective, and it's a parasite that grows very well in vitro. So there's no longer any need to perform any ex vivo or in vivo expansion in rodents. Now, in order to make it behave like a Trypanosoma brucei gambiense in the sense of the antigen expression, we have to perform several steps of genetic manipulation. And I'm going to spare you the details about it, but just to be brief, we have to know in the start the VSG that is occurring in the brucei. We have to lock the expression site there. Once we do that, we can introduce the LITAT 1.3 or the LITAT 1.5 VSG. And in the end, we have to replace the original VSG that was present in the strain by a novel selection antibiotic. And using this way or this genetic approach, we can lock the VSG expression of this strain. So when we obtained clones of it, we validated the LITAT VSG expression in Trypanosoma brucei by using a collection of mono and polyvalent rabbit sera. And what we saw is that there was 100% concordance with TB gambiense LITAT 1.3 or LITAT 1.5. So that means that we have made a Trypanosoma brucei expressing LITAT 1.3 that behaves exactly like gambiense LITAT 1.3, and a brucei that expresses LITAT 1.5 that behaves exactly like gambiense LITAT 1.5. So we're still stuck now with the fluorescent, the phase contrast microscopy. So we did the second round of genetic manipulations in these strains, and this round we introduced fluorescent reporter genes. So we made a Trypanosoma brucei LITAT 1.3 expressing. We made it green, so these are the parasites that you see in the green slide, and the LITAT 1.5 we made them red. So that means now it's a simplification of the sample preparation because we can mix both strains together and you have a nice readout because you only have to do one time the sample preparation. So this thing works with epifluorescence microscopy and we can even add a nuclear staining so that it's more clear to see where the nucleus and the kinetoplast of the strain is. However, we're still limited by the endpoint analysis. So the trypanolysis, it's always a technique that you need to do, the incubation for 90 minutes, and then you still have to estimate the percentage of lysis. So in order to improve that, we have to use a machine. It doesn't work in another way. And in our laboratory, we have a Tecan Spark 400. This is a kind of a plate reader. It's a 69 Wells plate reader. But the special thing is that it also allows to do microscopic imaging inside. And inside you have a 10-fold objective, and there are fluorescent LEDs that can excitate and record the emission that is occurring in one particular well. The nice thing about it is that you can take a picture every 15 minutes. So, for example, in 90 minutes, you will get from each well 6 pictures. And here in the Yeah. What the machine also will do is it will make an automatic counting of all the fluorescent strains that are present there. So it will just count the spots. It's a 10-fold objective, so the cells are pretty small. But it will count all the spots, and that will allow you to do a kinetic analysis. Because, for example, at time point 0, we still have 1,000 trypanosomes, and at 50 minutes later, we have 900, and half an hour later, we have 500. And the main thing, like you can see, for example, here, for the control reactions, if you start at 0 minutes, we still have all the trypanosomes left, and after 90 minutes, we still have the most, there is no lysis occurring. But when we test the case, at 0 minutes, we have 100% of the cells that are there, and at 90 minutes, the cells are obliterated. This allows us, because it's kinetic analysis, we can just make graphs of seeing the response that is occurring at the same time in these wells. And we tested this for the, we just tried out our technique with 120 parasitological cases, 120 endemic controls, and we compared it to the conventional trypanolysis results. And up to now, we just saw 1 out of 240 discordant, one result that was discordant out of 240 samples. Now, there's a way that we still, this is quite new, the technique, so we're just looking at, for example, if you look at the samples, you can see that the slopes of the reaction, they are not always the same. So there's some samples that will do a lysis very quickly, some samples that will do a slower lysis. And I think we can also, therefore, increase perhaps the sensitivity of the trypanolysis. Because now we're just stuck with an incubation time of 90 minutes, but if we can prolong the reactions up to 2 hours, then we will see more clear results. And hopefully also, because we can have a sharp definition of the control, it should be 100% after 90 minutes with a bit of variation of 10 to 25%. Maybe we can also lower the threshold of trypanolysis, because now it is set at 50%, but maybe if there's already 20% lysis occurring, maybe you can detect better, sooner what is going on there. Thought I had another slide, but it's not coming. Yeah, okay. Thanks. So in the end, I think we made kinetic fluorescence trypanolysis. I think we made the technique more accessible because it's now safer to perform and we don't need any animals anymore. It's high throughput because we can process 100 up to 200 samples a day, but there's still some limitations to use it. You have a high initial count and high initial cost for the imaging infrastructure, but per sample it's relatively quite cheap to do it. And at this moment, we just tested it on a limited number of samples. There is a call out for WHO where they demand a high throughput test for a verification of elimination. This test that we propose now, it has a similar specificity and sensitivity as the golden standard of TL. We still have to establish the performance on dry blood spots because that's also a requirement for the TPP. And this is an antibody-based test, so we have to exclude former patients from the analysis. And in the end, also I think the idea is to commercialize this test, but I'm not sure whether this is able to commercialize, but we're getting pretty close as another alternative. So, that's it. Thank you.
Thank you, Nick. Je pense que avec la présentation de Nick, nous allons clôturer la sous-session sur les diagnostics de la THA. Je pense qu'hier, il y avait aussi certains participants qui avaient des questions pour...
Some questions on yesterday's presentation. We are going to open the debate following this presentation, a series of 5 questions regarding presentation of today and yesterday. What we are going to do, we will diversify countries and partners. Sierra has the floor. Do you have a mic? Thank you. Omar, on today's presentation by Lucas, if I understand well, the PCR and Elisa were made on the same samples. If that is the case, there is a discrepancy, which means that I have to, if antigen polymorphism are they documented? Thank you, moderator Patula Nzobo from DRC. My question is to Lucas. Many questions arose from his presentation, and also a question. If I understand well, there is a treatment not only of cases, parasitology cases, but confirmation cases, parasitological confirmation on molecular and others. I want to know what is the following. Do you have a follow-up program other than the only parasitological case? If that is the case, what are the results of the tests following the test? Thank you. Philemon Manti Issa from DRC. My question is to Prof. Patti. He said in his presentation that they didn't find TB gangensis in animals following the survey. And I remember 10 years ago, we find hearts in Malanga with TB gangensis 10 years after. My concern, where were these Glossina infected? We could deepen the survey on mouses and others. Where are the reservoirs for TB gangensis, which we find in some Glossina in that area? Thank you. Dr. Muyolo Madibi, RDC, DRC. My question is for Patti and Nick Van. We know that on the surface of trypanosomes, in hematogoto protein, which modify frequently, the variation of this protein, known as VSG, changes epitopes. My question is, the variant will not. Also for Professor Dongo, how do you select antigen for trypanosome, for THA or for animals? The last question. Patrice from DRC. My question is for Lucas and also to all those who talked about release and PCR. When we look at the time between diagnosis and the time for the treatment of a patient, it takes 3 months. Why? When we do a screening, what is important is to find a solution to cure the patient. But what happened after 3 months? And we know that trypanosomiasis is within population, within people who are not sedentary. How do they improve the situation so that the patient is treated as soon as possible? Because if diagnosis takes long, it's difficult to treat the patients. Nick, vous pouvez répondre. Concerning the surface of the trypanosome, it is about VAG, so the aim is to identify what is on the surface. Without that, so I don't know if I have responded to your question. Well, now concerning the question of Central Africa. This question was
Nick. Je pense que c'était Nick. Hein? Toi, tu t'es adressé à Nick, non? À Lucas, ok, merci. Lucas, tu peux répondre.
On peut répondre en équipe, hein, pas de souci. Donc oui, pour la première question, la discordance des résultats, tout à fait, c'est quelque chose que bon, j'ai pas les réponses exactes et je crois qu'en ce moment personne les a. On a certaines hypothèses, comme est-ce que la chaîne de froid, ça peut peut-être partiellement expliquer pourquoi il y a que 4 PCR positifs, pas 16 avec 16 trypanolyses.
This positive trypanolysis is something can explain this discrepancy. It is now the old cases. When it is about the old cases, so sometimes they didn't understand very well, and we still have the old cases. So now for serologic screen, it can take more time. For trypanolysis, we have also the result, but this case is especially for experts. It could be also changed quickly, and we play with the idea to screen all the patients which have been confirmed. Then when they are called for the treatment, so we have also to do another screening to see if the result can be confirmed. Otherwise, we'll have also to continue talking to other partners. But from that, Nick and Opati can also complete, because I don't have technical answers on this case. For the other question concerning the treatment of trypanosis, for up to today, the case but we don't confirm the test after treatment. So to be sure that, okay, it was successful. If I'm not wrong, we can also do the punction Lambert to see if the white cells are still there, but we have also to count the white cell, and we don't do it for for all patients. So the follow-up is especially clinical, and we don't have, cases of death. And now to conclude on the questions about the timeline between the result and the time we have taken the samples. At the beginning, we wanted to be a maximum of 3 weeks, but we have a challenge, and it is not easy from one time to another one. So the test, we are testing a lot of samples. So we are at the beginning of the project, and we are trying now to investigate how we can also decrease this time between the collection of samples, and we are trying now to see if we can't have a second laboratory in Buji-Mayi, so we can have also more tests for confirmation in Buji-Mayi. So now the timeline can now decrease between the collection of samples and the results. But up to today, we didn't find, these patients to treat them. So we are trying to put a system, and we are trying now to work with the community. And now for the conclusion, so we have also to track these patients in the community. So it is part of the performance that each patient should be also treated. But the question was if you can also continue your investigation to other wild animals. And at the end of we can give also our own position according to the different question and observation. Yes, Pati. Thank you. I want to answer to the question who was asking about the VHSV. It is just small. We have to be very quick. We have in all these trypanosomes we collected in Central Africa and also in Central Africa, the expression of 1.3 and 1.6 is very, very big. That's why we made now this clonage. And we had this literature 1, 2, 3 that we try also to collect. Now this is what now we are using to make the test of trypanolos. Whatever the number we can find in the this sample, it is now expressing this sampling. So we are trying also to reduce. So the focus is on these two antibodies. So we don't have really to compromise. According to the question of Mr. Sisa, so we have found that we don't know if at the level of that cycle of trypanosome, we don't know what you have found. Was it now the cycle of infection to now affect also these animals? We have made some study. We are at a level very far, and we found that it is only the species, the subspecies. So we are trying now to continue to found. Stephen.
So how did we identify the antigen that we use? So nothing much was done other than just getting the total live set of Trypanosoma congolensis and injecting in a camel, alpaca in this case. So as per now, we know also there are other methods that people were trying to suggest to me. They said, why don't you go for a recombinant protein where you start from bioinformatic analysis of this protein that are immunogenic, abundant, and then having unique epitopes. We said, no, since we're interested in a native protein, let us try by going with the total life set of the trypanosome, and then we can, from there, try to work backward. So we went with the total life set of trypanosome congruency, we injected in alpaca, and then thereafter we got a nanobody that was binding to a protein that we didn't know, and we worked backward through a pull-down assay, and we found that it was binding to a glycolytic protein, what we are called enzyme we are calling aldolase. So that is how we got to this protein. Thank you.
Okay, thank you. Peut-être pour clôturer cette...
Maybe to conclude this session, I want also to know what is now your position from WHO. I want to save time. I want to formulate a recommendation to facilitate the work of the rapporteur.
Charles, I would say that in view of the lack of correlation between the results of the post hoc confirmation tests, it would be recommended to continue the performance, to evaluate the performance of those tests, including the new tests.
Ok, OMS, José Ramon ou Prioto, je ne sais pas, vous avez des avis?
Bon, peut-être, maybe what we have seen, we are trying to express. Unfortunately, up to now, the diagnostic was based on the microscopy. Today, we are now losing the capacity of screening, so we have less possibility. Unfortunately, this is the reality, and we would go to have tests of reference. We had also some interesting experience. There is still a work to be done. And we have also some differences, but we have also some improvement. But we have to work more and more. I want also to remind you that at WHO we have also a group of experts who are trying to define the screening. We have also our target, and we are trying to see what do we need in this capacity. I'm very happy because we have many groups of researchers who are working on this area. So I'm encouraging them to continue working, and I'm sure that somehow we are going to improve the standard. We still have enough to improve. Thank you. Thank you.
The next session, maybe a quick comment from Chairman.
Thank you very much, Mr. Moderator, the Rapporteur. It has been a very stimulating discussion. I want as Chairman to also make my contribution. The diagnostics field is a very dynamic one, and we are going into a phase where the tests that we are using today, we need to use them in a much more judicious manner, especially when we are talking about the disease numbers going very low. And one of the tests that we are depending on heavily, it has been referred to as the gold standard today, is the trypanolysis test, which is an antibody detection test. And those of us, because we have scientists, we have people who have laboratories that are housing some of these parasites, I think we have an opportunity as we are talking about One Health. We were saying on Monday we need to find ways of mobilizing funding to address the One Health approach and the human and animal disease at the same time. We need to figure out, because the triple analysis test detects antibodies to a variable antigen that is on the surface of the trypanosome. And those of us who are familiar with the biology of the trypanosome is that the RITAT13 and RITAT1.5 antigen, at one time during the generations of the trypanosome, the antigen will be expressed. What is the significance of that when we come to livestock trypanosomiasis? And do we have an opportunity to address this question, to understand how this gets expressed? So we need to look at this with a view of asking ourselves, can we mobilize resources? Because if we do this work using animals, any animal that you identify, you treat it, and that contributes to the control of animal African trypanosomiasis. Thank you, Mr. Moderator.
Thank you, Professor Joseph. With this comment, we can close the subsession on at diagnostic, and we are moving to the second session about stratégie de dépistage de la THA.
So how we can do the screening, we are going nous allons.
Dr Mathieu Nkieri. Il va nous parler de stratégie.
Going to talk about the strategy of screening. So now for 10 years, there was another study going on. So you have 10 minutes.
Bonjour à tout le monde. Nous remercions le présidium et la modération.
The chairmanship and moderation for the given to us to we have done in Bagata. I'm Dr. Bagata in RDC, also researcher for clinics in General Hospital of Bagata. We did a work on non-endemic villages in Bagata rural. We know that right now in our country, as presented by everybody, the disease is going down. During that period, we should look for all venues. We say that the prevalence is low. Health system is low. Even the campaign for is low. Infrastructure, basic infrastructure is non-existent.
Alors, cette situation des anciens foyers doit nous tiquer parce que on peut encore.
We could still, after the effort of the disease, 1916, and all our effort will be in vain. There was other studies carried out in some countries, namely in Gabon, Guinea, and we said that we should try what are epidemiologic profile of this disease in Bagata, so that we work on it. Our objectives, as we said, we want to document that serological studies, but we will use inactive research. It's we, the actors on the field, we should find the profile. We look for all the foci. This is Bagata Center. We are at the west, 635 kilometers from Kinshasa, in DRC. We have 516 centers, health centers, and they are endemic in THA. In Bagata Center, there is a package of THA, but also we have a presence of mobile current. Here we are in our team. We have a member of a mobile unit to give us here we have a lab and the confirmation with a microscope, camera microscope, to see what is happening during this low-level prevalence. We identified 19 villages and mapped, and we work with communities. They have to help us. Nurses, all the community have to help us do the screening. And then we did a chronogram, a calendar. All these suspects were brought back to the general hospital to do the parasitology screening. And some people came by themselves to do the screening, to be screened. What are the results we had regarding our studies? On the 19 villages we had, we visited 9 villages because the work was not completed. We treated 7,300, and some on the suspect, they were subjected to mini-colon, and from the 51, 7 were positive. 1 and 4 in stage 2. We presented here the villages we visited. We visited 9 villages which are screened. What is more important, the 4 villages which were non-endemic but which became endemic and went into the normal system of mobile unit for a new reprogrammation. If we didn't go to the villages for the follow-up, they would become non-endemic, and we would have an epidemic in that village. But with this village, we managed a village, and the village became endemic. In Burkina Faso, we also did the study, and in Gabon, but here in our case, the service provider went to do that studies, but we have encountered many difficulties. Problem of equipment, transport of a patient. But what we can do is say, if, for example, the health centers around the villages are equipped, the patient, the suspect, we not go through a long distance, and screening can be done easily. Yes, but also, in conclusion, we can, during that period where there is a low prevalence, this could give us the image of what we have to do. Otherwise, we will do the elimination, but there will be a resurgence despite all the effort made. We should put in place, we have to work hard. Penalty, providers, community have to work together to eliminate and eradicate the disease. All the strategies have to be explored. Then it would be possible. Thank you. We say thank you, Penalta, and the community who worked will help us to reach that result. Thank you.
Merci, Dr. Mathieu.
Thank you, Doctor. The second presentation will be done by Rashid Lee on the challenge of the human trypanosomias and also the non-confirmed case. So you have 8 minutes, please. If you can try to focus on the result and less more about the introduction.
Moderator for giving me the chair. I'm Rashid Hassani from DRC. Yes, I will present you this topic related to one of the challenge of sleeping sickness. So the topic is human Africanus trypanosomiasis, challenge and perspective of unconfirmed suspect case. Yes, I will share with you, so you can come back to the previous one. This is just to remind you, human Africanus trypanosomiasis is a vector-borne parasitic transmitted by the bite of tete flight. Just to remind you, I mean, yesterday during the WHO presentation, they talk about the history of human African trypanosomiasis, when during the 20th century, many epidemics occurring in many African countries, and then kill many people. And for that, a broad alliance was made between endemic country, financial and technical partner under the leadership of WHO, and this pooling effort bring the prevalence in the low level, as we see in the slides of DRC, who is the country with the higher burden of disease. So in this context of low prevalence, the agenda set is to stop the transmission by 2030. So to reach this goal, several challenges remain, such as this challenge of unsuspected case confirmed. So to understand topic, so first of all, we must understand how we leave the higher level to the low level. The basic strategy, as they told us yesterday to the keynote, it was the screening, parasitological confirmation, and the treatment. So to understand this topic, let us zoom step by step to the strategy. Slide. So about the screening, so we use serological tests, maybe CAT test or RDT. When the test is negative, there is no case. Where the test is positive is the suspect case, and the suspect case for the confirmation. And for trypanosomiasis, the confirmation means to visualize the parasite through the microscope. And then if is the case must be treated. And now for this strategy, what is the issue? Slide. The issue is about the sensitivity, which is not 100%, which means that, slide, some serological suspects remain unconfirmed, and we think that if those unsuspect cases not confirmed are case, they may constitute the reservoir. In this case, there is this risk of continuous transmission. In this case, it will be difficult to reach this goal of elimination. So there is a good news slide. So the discovery of the new drug of acoziborol, which is a non-toxic single oral dose. After one multi-centric trial made in DRC and Guinea, they show that there is this efficacy of 91% of efficacy, regardless the disease stage. And also, when we compare acoziborol to other trypanosides, we notice that there is no need of lumbar puncture and the short duration of treatment. With this advantage slide, so the discussion is now to shift the approach. Instead of screen, parasitological confirmation, and treat, so in the future, we are going just to screen. If the case is a suspect case, we are going to treat it. Is here our statement in this study. We say that, is it feasible to use serology as a basis for presumptive treatment in the low setting prevalence of the disease? And then we have, there's three purposes. We are going to compare the trend of new case and the serological. The first one is to explore the trend in proportion of confirmed Gambian human trypanosomiasis among persons actively screened in different endemic regions. The second one is to explore the trends in proportion of serological Gambian human Africanus suspect among persons actively screened. And the third one is the confirmed G heart case. This is the methodology, so I will go fast because of time. We can go directly to the results. So the study is in DRC 11 coordination. It's just a descriptive study. We use annual report of 11 coordination. We use R studio, which help us to perform scatter plot and trend analysis. We use the man-Kendall tests to check if this trend was really the real trend. So, about the result, I will just present the key finding. So, the first in two levels, the national level and the provincial level. Here we see the national trend in proportion of cats and the infection rate from 2010 to 2022. So what we notice that the trend of infection rates decrease over time, while the trend of proportion of positive cats doesn't follow this trend. Slide is the same case in Bandundu. Decrease of the infection rate doesn't follow the trend of proportion positive cat. Slide. But it is quite different. The same trend, there is some kind of overlap of the two trends. The decrease in infection rates and the proportion of cat tests. So, let us go. Slide. Slide. So here is just to show that there is no issue about the specificity of the tests. They told us yesterday about the specificity of the cats. Again, slide. We noticed that the PPV is very low everywhere. Slide. And about the suspect case, just for 2022, we have just 7590. Slide. Yes, ongoing this results, 3 elements point out as a discussion. The first, comparing the trends across different regions, we noticed that in Bandundu there is this decrease in proportion of Gambian human Africanus trypanosomiasis without any correlation. To other regions, there is some correlation. So for that, the specificity of each region may explain those disparities. Again, when we compare the PPV of our study, the study conducted in South, that our PPV is very low, and we assume that the difference could be explained by the follow-up design and the difference between the level of prevalence in 2 settings. Also, the number of suspect cases is less than 10,000. Our question it was, is it feasible to treat serological suspect? We say that yes, because the number of serological is really less. You can master that, as is less than 10,000. This experience was made in Equatorial Guinea, as reported by Simaro, Pere, and all. Yes. To conclude, we say like that. We have 3 key messages. The first one, we say in this context of low prevalence. In this context of low prevalence, this approach of screen, confirm parasitologic, and treat is any longer effective. And also, we know that to stop transmission is quite complex. We need, yes, to use a multidisciplinary approach, such as the one-of-one. And we assume that by using this approach of treat, screen and treat, we are going to avoid to miss case, and we think this approach may help the program to accelerate this goal of elimination. Thank you.
Dr. Rachidi. The next, Dr. Albert Niembo, qui va nous parler de la recherche active chez les individus séropositifs non.
To talk about
You have 10 minutes. Thank you so much, Mr. Chairman and Mr. Moderator, for giving me the floor. I'm called Dr. Albert Nyembo. I come from the DRC. I'm going to make a presentation of some work which was carried out in this country with the initiative of the National Control Program against trypanosomiasis in collaboration with DNBI. This is now the structure of the presentation. There will be some small introduction which will be followed by the objective of this work, and also we are going to talk about the materials and methods, results, discussion, and conclusion. Up to now, the protocol which is being used in the DRCs requires that all cases of sleeping sickness should be parasitological confirmation, and the protocol in a general way is that one. These are parasitological cases. In the same logic, this also affects practically the treatments. So as to go for treatment, you have to be a case parasitologically confirmed and having gone through a serological test, TDR and CAT. Up to now, despite all that the techniques which exist in the country, like CTC, like mini-colon, there are always a big number of serological suspects which are not confirmed parasitologically and which are there in the nature. For example, in 2020, the country had to diagnose this number of cases, and using CAT and TDR, this represents practically 2.4% of serological suspects confirmed parasitologically. It's the same thing for 2021, where there were more than 400 new cases out of the serological suspects. In the same logic, in 2022, the country already given that data, 516 new cases, as you can see. So these results give us an idea of the number of serological suspects which are there, at the end of which we are having taken out those who are parasitologically confirmed and put under treatment. So there's the necessity to take all these suspects and then go for the examination for trypanosomiasis. The objective is to try to share this experience of the active research and to bring them for trypanosomiasis to see what that gives, to see the serological status of all these patients who are non-confirmed suspects. Here we do present to you the map of the DRC, which had already been presented, and also the part in red represents practically the zone which this study was carried out. So this concerns South Bandano, North Bandano, Kasai, West Kasai, East Kasai. This is some work which was on the four areas most endemic of the countries, and these were based on 14 health zones in these provincial coordination centers. On the right, the map on the right, I don't know if you can see it clearly, but all the points in blue are actually motorbikes, which shows the circuit of transferring filter paper from the appropriate structures and which are sent to Kinshasa so as they can be examined, the trypanosomiasis test. At the origin, this is a project which started at the beginning of 2020, and in 2020 we had already created these networks for the collection of filter papers for trypanosomiasis. There was the selection of the different centers of screening, which could do parasitology and also use filter paper for trypanosomiasis. After all this step, there was now the step of training, which was first of all constituted by the training of trainers, which involved practically the training of about 30 laboratory technicians, and this was followed by more training in the 4 areas of coordination, and this actually worked. This training involved more than 400 service providers in order to be able to use the filter paper. The tests used at that time, after identification and after taking samples on these serological suspects, there was use of minicolon for verifying the states of these suspects, and then all the negative cases were sent for trypanolysis, and then the suspects who were positive after trypanolysis tests were immediately followed to see how they would behave with time. If you can come back a bit behind, I would like to give some small explanation on the way the thing really happened on the ground. On the diagram on the right shows how this activity was carried out, and all started from the screening and treatment center, where practically the blood samples were taken, and also the filter paper is used. This was under the responsibility of the supervising nurse in charge of the center, and then they take the samples and they send that to the provincial coordination level, who gathered all the filter paper coming from the different areas. And therefore, the provincial coordination verifies the conformity of these samples and the verification of the codes, because there is need for a big organization regarding these samples. And also there's the issue of confidentiality. So all that work is done here at the coordination level. After verifying all that, the coordination sends the samples to the National Directorate in Kinshasa. And then in Kinshasa, there's another verification, and the samples are sent to INRB, which analyzes the samples and makes reports for the National Directorate. And also there's immediate contact with the center which took some of these samples, so as to have more supplementary information. The eye played the role of monitoring. After results arrive at INRB, there is now the arrow which shows the results, which goes to the National Directorate, and then the coordination, and then the structures which have the infrastructure for sample collection. I'm not going to talk about that because on the left, the diagram is just repeating what I've just said. So these are practically the results of the work which was carried out. As I said earlier on, the work was done in 4 provincial coordinations. What you have to retain here is that the isolate used was LIT 1.3, LIT 1.5, and the final results are below. The total number of filter papers sent to NBR was 690. Out of this 690, we have practically 21 which came back 21 positive, and we have 17 which came back 17 under LIT 1.5, which makes a total of 38 cases which became positive after trypanolysis, out of a total of 690 samples sent to NBER. We also worked in some other countries, and here are some results. Notably, these are results given by Burkina Faso in 2012, and it is some work which was linked to the activities of Mr. Kambere and al, and then they found that out of 23 filter papers sent to the laboratory, there was none which came back positive after the trichinolysis test. And also they worked in Cote d'Ivoire, Kambere and al. Out of 6 filter papers sent to the laboratory, 3 were positive after the trichinolysis. So in a general way, without trichinolysis, all these suspects will not be found, and there will be no confirmation of the new cases which we have there out of the 38 which became positive after trichinolysis. That is the results for 2022. In conclusion, we are saying that in the context of low prevalence of HIT, which has been mentioned, we think that trichinolysis combined with other techniques would be a means of optimizing and monitoring correctly all these seropositive individuals, non-confirmed and confirmed in endemic areas. And given that, as I said earlier, since it is some work which was carried out in 4 provincial coordinates, ISCTRC has 11 of them. I would say this was a pilot study, and if we went on scale on all the 11 coordination zones, we would have more cases, more than the 8 cases if we went to scale. For now, if we have to capitalize the activities, there are 3 other positive new cases which was through trichinolysis, which was added to the 8 other cases. So if we have to consider all the data up to 2023, the country has up to date 14 cases thanks to the trichinolysis examination. This is the work which we did in the DRC, and we wish that it should be supported and be put to scale. Thank you so much. The next presenter is Patu, who is going to talk about the effectiveness of new methods for HAT, which was carried in 2 health districts in the DRC. You have 8 minutes.
Merci. Thank you, moderator, chairman. Patunga Zobo is my name, from Congo, DRC, as one of our coordinator. We will talk about efficiency of screening method to eliminate THA. This is a project under the coordination of Bamdondo SAF, which is a neighbor. Is a focalizer disease. It's not like we have our villages where we found trips, THA, and with WHO, we are trying to eliminate that disease by 2020. Suppose there's a burden of THA in DRC according to the last data, in 2013, 64% it has been proved. But unfortunately, with the local coverage at country level, we came to 28%. There's still a lot of effort to overcome that situation. We reached 3 times the threshold of elimination. The representative of director presented the data. The project was carried out in Kwilu provinces, one of the provinces of DRC, but mostly in 2 health centers, Mosango and Viava. Here we have all these images. WHO presented this, but we focus on the last 10 years. We have new cases. We are trying to going down. We are reaching elimination, but is this real? Considering the coverage, which is still low, 30% only. So there is a lot of questions. This was the basis of our studies, the study we carried out. To come back to this result, in active screening, there is the algorithm of WHO where it was recommended the villages which have mentioned one case or in the last 5 years, 3 cases. For that, villages which were supposed to have bring back a case. What happened in villages which are neighbor and which were not endemic, while these villages are within the same culture, biotype, in the same context. Our project had 5 innovations. We will name them briefly as the first one, where instead of mobile unit, we introduced mini motorbike, where we have 4 agents. As that innovation was within that the program, and we did a door-to-door screen instead of a mass screening. First, we did the digitalization of manual collection and stocking of data. Fourth, quality control with the image taking of cases that were positive in TDA or TDA particularly, or video taking of positive parasitological cases. Fifth, innovation. Fifth, which was the focus of our exam, non-endemic village in the neighborhood. We had a buffer of 5 kilometers in villages, or on endemic villages. You have the representation of villages which are endemic and non-endemic villages. Our objective is to assess these active assessment. The villages which were not endemic. We were again going against the standard of WHO. If we should prove that this is a work that is essential. That was the methodology. Here, we have maps that were confined. We put together villages, qualified and unqualified, which brought back cases. And during the 3 years of the implementation of our project, these are tables which are more visible. Here we see that over the 3 years period of the implementation of our project, villages brought back cases. 32% of the village, of the whole village that brought back cases, qualified and non-qualified villages. 32% of non-eligible villages. It was important for us to look at these villages. But we have a similar case with Kofi in 2017, but he didn't use the strategy of neighboring villages, but neighboring foci which have cases. They found the same percentage of number of cases, and the number of cases brought back as a whole, 2 new cases, 32%, which came from non-qualified villages. It is important for us to have screen that studies. 2 questions. Should we continue to neglect these non-eligible villagers to find cases? How are we going to ignore them? Are we going to talk about elimination on villages which should not be visited? One of my colleagues showed that the village where screened 10 years ago brought back cases. We think that we should have the courage to revisit our algorithm so that neighboring villages in the same case or non-endemic should be visited. And I thank you very much. Thank you. Thank you. Before breaking, we will do the last presentation by Moise, Special Surveillance. The case is in Guinea, 10 minutes, no more. Morning. My name is Moise Kababuno, entomologist in the national program in Guinea, in charge of campaign against parasite. Yesterday with my colleagues who mentioned that the strategy to fight sickness disease is adapted. We use a program to in an adapted manner to carry out the campaign. Our anti-CC campaign and the medical campaign contributed immensely to the reduction of the fly density, which has an impact on the transmission of the disease and contributed to the reduction of number of cases. In so doing, we set up other strategies. And these strategies here are based on a pattern I was saying that the program adapted strategies in the context of elimination and going forward transmission. These strategies are focused on the targeted campaign, giving us the opportunity to integrate interaction between screening, target assessment, and the campaign against the disease, following space monitoring. The general objective is to reach the stoppage of transmission, and the specific objective is to identify space which might lead to the disease, and to target anti-CC campaign and integrated at community level fight against THAT. So in so doing, around 8 patients identified in 2 foci. We did space monitoring with 4 phases and with 2 steps. In the first stage, we realized we had an interview with a patient, and this can also happen in a household context. In the second step, we tracking, identify patient where in the work space. From there, we identify spaces. This was happened with a model color tracking, OMS tracking. And the patient have to help us to identify hidden patient. Then we carried out an entomological survey. Following this result, we deploy a reactive component. The result we had in the breaker foci, we identify zone and where the patient is, and following antivectorial study, the patient extracts salt, and in other foci where there is a vector, Many activities were carried out, namely salt extraction, rice culture, and these activities were carried out by other villages, from other villages. The scenario here, we happen to have an epidemiological model which entertain the propagation of a disease, infection in new areas, focus. In the Focaria area, we identify 3 areas. And what we notice here, the patient share 2 spaces, where there is a anti-CC and where there is no campaign. The epidemiological model we have, this could lead to entertaining a foci or a focus. Following this result, we carried out a survey, a door-to-door survey in a very important zone. In that region, in that zone, we tested 947 people where we confirmed 5 patients, which means that the space monitoring is efficient because we have to intervene less in an area, which means that the steps, space methodology can help to find zones and reduce the effort with a result which is favorable. To conclude, we can render that space monitor to identify new spaces of sharing of transmission risk, to find hidden pocket in those foci. If we, for elimination, we have we may find a hidden pocket. We can carry it out in a coordinate manner with a medical and a medical approach, but that approach can be considered for the elimination and to stop the transmission by 2013 and favor the interaction between teams on the field. I cannot finish without thanking the actors, partners contribute to carry out that study.
Beaucoup. Et nous allons
Thank you so much. We're going to stop here for the coffee break. I give the floor to the chairman.
Thank you very much. I appreciate the discussions, and just a small contribution to the presentations by Kaba and Guinea. Will make some contributions there. But before that, I have a short announcement to all the member states. This is in relation to the nomination of regional representatives to the Executive Committee of the ISCTRC. This is the requirement by the ISCTRC Constitution that the different endemic regions of Africa are represented. And these are the regions: Western, Central, Eastern, Southern, and Northern. What we would require is that the delegates who are present in this conference from these regions nominate a representative who would be presented by Friday morning for endorsement by the members. So the positions that require to be filled are as follows, and we require 2 members from each of the regions. So for Southern Africa, we have Dr. Constantina Machado from Angola, and we have 1 vacant slot following the retirement of Dr. William Shereni from Zimbabwe. From Central Africa, we have 2 slots that are vacant, and these have arisen following the unfortunate death of Dr. Dutamia Anaklet from Chad and the transition of Dr. Lisette Kohangne from the government. So the delegates from the Central African Republic, we need you to meet and propose 2 delegates from that region. From the Eastern African region, we have Dr. Beyene from Ethiopia, and we have 1 slot that is vacant following the retirement of Dr. Baba Sall from Senegal. Sorry. I'll repeat that. From Eastern Africa, we have Dr. Beyene from Ethiopia, and we have 1 slot that is vacant following the retirement of Dr. Pamela Olet from Kenya. From West Africa, we have Dr. Yahaya Andam from Ghana, and we have 1 slot that is vacant following the retirement of Dr. Baba Sall from Senegal. From Northern Africa, we do not have any representative, and therefore we have 2 slots that are vacant. So delegates from these member countries, please meet, nominate the representatives to fill those vacants. This should be submitted by Friday morning. The Executive Committee of the ISCTRC also includes executive members who participate in the committee meetings. And these include the AU-IBA, the AU-PATEC, the FAO, the IAEA, the PAAT, the WHO, ISIPE, IRRI, SILDES, WOA, and similar organizations. So these are the members of the ISCTRC. So for this week, before Friday morning, we need the delegates from the various regions to submit their nominations. So I thank you very much, and I wish you the best as you continue with your discussions during coffee, and we come back here at 11 in order to continue with this very tight program of today. Thank you very much.